So let's get this conversation started. I'm Dan Hooper. I'm going to be kind of moderating or leading the conversation, but I think you're mostly here to listen to these fine gentlemen. So tell us about Oumuamua and your personal journey of how you learned about this object and how you got to your eventual conclusion. Well, I won't even tell the audience what your eventual conclusion was. You can tell them.
Okay, well, the story actually starts much earlier than that. I was born on a farm, and I'm fundamentally a curious farm boy. Nothing more. The fact that I became a chair of the Harvard Astronomy Department is completely irrelevant, because I maintained my innocence in the sense of not listening to the adults in the room. Okay, I refuse to be the adult in the room. I just want to attend to evidence. Now, I'm not original in that. Some of you may have seen the World Cup this summer, the Women's World Cup, and you realize that FIFA, in deciding whether there was a goal, is not paying attention to what the players say. Okay? They are not paying attention to what the audience is saying, which is pretty much what Garrett was talking about. They use cameras, video cameras, to decide. That's the work of a scientist. Use instruments. People are not reliable. Okay? That's how science works. Now, the reason I went to science is I was traumatized as a kid, at the dinner table, asking difficult questions, and the adults in the room would just dismiss the questions just because they didn't know the answer to those questions. Because adults are very often motivated by showing off that they know much more than they actually know. So I thought to myself, great, I'll become a scientist so I can answer the questions myself. And that's what happened. It's not so much that I wanted to be the chair of the Harvard Astronomy Department, I just wanted to figure out nature. And I did my job as chair just as a service. It's more like being a server at a restaurant. You help other people. I just wanted to improve my academic environment, but it wasn't really my passion. Then in 2017, the first object from outside the solar system was announced by the Pan-STARRS telescope in Hawaii that was aiming to survey the sky to find objects that might impact Earth. Because the Congress tasked NASA to find 90% of objects bigger than a football field that may impact Earth. So the Pan-STARRS survey telescope was assembled, and then they saw this object coming close to Earth. They flagged it as a near-Earth object. That's the only reason they pay attention to it. If it was farther away, they would ignore it. And then they realized, oh, it's moving faster than the escape speed from the sun. Therefore, it came from outside the solar system. First time. Now, to me, that was a shock, because a decade earlier, I wrote a paper saying Pan-STARRS should not detect any such objects. There are too few of them. If you do the calculation using what we know about the solar system, and you just apply that to all the other stars in the Milky Way galaxy, you can estimate how many rocks should be ejected from planetary systems that would fill up interstellar space, and every now and then one of them would come close to Earth. And you do the calculation, you see that Pan-STARRS has no chance by orders of magnitude to detect anything. So then this object was found. So I thought to myself, wow, that's actually, being wrong is actually a way to learn, by the way. That's what I tell my colleagues. They refuse to listen. They want to be right. Most recently, we will talk about that. I went on an expedition to the Pacific Ocean to go after the materials of the first interstellar meteor that came actually 4 years before this object was discovered. And then I saw my colleagues saying, oh no, the data on this object is incorrect. The US Space Command doesn't know what they're talking about because we cannot fit the data with our model for stones. And I call that the Stone Age of science, when you're not willing to learn anything new. Everything in the sky is stones. Anyway, that was the assumption about Oumuamua, this object. And it was called Oumuamua because it means a scout in the Hawaiian language. At first I thought it's a rock. It's just that there are more rocks than we expected. But then the amount of sunlight reflected from it changed by a factor of 10 as it was tumbling every 8 hours. So it had a very extreme shape. And moreover, and most likely when people fitted that shape, not me, other people, they got best fit at a 90% confidence for a flat object, pancake-like. And then there was, the object exhibited a non-gravitational push away from the sun without showing any sign of cometary evaporation. There was no rocket effect that was propelling it. And the only thing that sounded reasonable to me is that it reflects sunlight and it's getting pushed by reflecting sunlight. But for that to be effective, the object had to be very thin, sort of like a sail, but it could also be a surface layer of a bigger object. And nature doesn't make thin membranes of this type. So I said, maybe it's space trash from another civilization. You see sometimes plastic bags stumbling in the wind, right? Now, at first, the paper was accepted for publication. Within 3 days, the referee said it's a great idea. And in fact, this object, the referee was on the original discovery paper and said, we have evidence that this is most likely a flat object consistent with your conjecture. So I felt good because I came from cosmology, where we don't know what most of the matter in the universe is. It's called dark matter. So it's encouraged to come up with hypotheses that can be tested. That's part of the culture. But something different happened here because the public was extremely interested, and reporters from all over the world. The following day there was someone at the front door of my house with a camera saying, "Do you believe that we are not alone?" I said, "Sorry, I have to go to the airport." But anyway, I got to Germany and there were like tens of reporters waiting to speak. So there was a huge amount of attention, and I tried to explain, and then my colleagues started to get upset about the publicity. And they said, no, it was natural. So then one team said, oh, this object was definitely natural, but it's a rock of a type that we've never seen before. It may most likely a hydrogen iceberg, so that when it evaporates, you don't see the cometary tail, so it's transparent. And we showed in a paper that that doesn't work because a hydrogen iceberg that we've never seen before, that has to be produced in a different environment like molecular clouds, such a thing would not survive the journey. So then another team said, oh, we found it. It's actually a dust bunny. A cloud of dust particles that is 100 times less dense than air. Just think about it, 100 times less dense than air, held together, pushed like a feather by sunlight. And I said, well, but it won't survive coming close to the sun. It will disintegrate. So then another team, a few months later, said, oh, we found it at last. It's a nitrogen iceberg, chipped off the surface of a planet like Pluto. And I said, well, we've never seen that before. But actually, if you calculate how much mass there is in solid nitrogen in the Milky Way galaxy, there is not enough to make up for a population of rocks made of nitrogen. That will explain Oumuamua. And so this guy became extremely upset, and until today he keeps telling reporters how natural Oumuamua must be. And and then most recently in Nature there was a paper published saying that it's a water iceberg turned into a hydrogen iceberg, a variant on the hydrogen model. Anyway, my point is, it's not easy to explain it. You can't deny the fact that there is an anomaly here, because otherwise why would multiple teams of astronomers dedicate months of their time to explain it without great success? And by the way, they just explain the non-gravitational acceleration. So the moral of the story for me was, science is based on evidence, not on eyewitness testimonies. It's based on evidence collected by instruments. Let's go after more evidence. And then we discovered a meteor, an object that collided with Earth. Oumuamua was the size of a football field. This object was half a meter, size of a watermelon. Collided with Earth back in January 2014. The US government satellites recorded its motion. It was faster than the escape speed from the sun. Not only that, but it was moving at 60 kilometers per second outside the solar system, faster than 95% of the stars in the vicinity of the sun. And when it exploded, it was low in the atmosphere, so it was able to maintain its integrity to much higher stress than any space rocks cataloged by NASA over the past decade. So we said, well, maybe it's a Voyager-like meteor. Imagine our own Voyager colliding with an exoplanet like the Earth in the future and burning up in the sky like a meteor of unusual material strength and unusual speed. That's a valid conjecture. And these critics jumped at me and said, how dare you even bring this up? The data must be wrong. So they blocked the paper, and then the US Space Command issued a letter to NASA saying, we confirm at the 99.999% that this is interstellar. So then our paper got accepted, and then I planned an expedition to look after the materials of this object. And then these critics were saying, oh, you will not find anything. And we went there this summer in June and found the materials and analyzed them with a mass spectrometer, found a composition different from solar system materials. And the critics said, oh no, that's nothing, you didn't find anything, that in fact it was a stone. I just say, well, there are pro-truth pretenders that we should all unfriend. Because just like in George Orwell's book, they could say war is peace, ignorance is strength. And these are people that are fighting to save science when they are violating science. Because what science is about is doing the hard work of collecting the evidence. What they're doing is expressing an opinion, sitting on a chair doing nothing, and just saying bad things about the people who do the hard work.
So, Avi, I want to ask a question that's in the same spirit of the one I asked Garrett a minute ago. So, let's just think about Oumuamua as a concrete case. When you take all of the data, all the evidence, all the reasoning, all of the arguments that have been placed around it, what probability do you think is fair to estimate that this is extraterrestrial technology? Artificial, something made by advanced civilization?
I will not assign a probability. I would just say it's a possibility that is worth figuring out by collecting more evidence. So I'm intrigued by it, and I'm trying to find out whether it's 100% or zero. I think it's arrogant of us to assume that we are the most intelligent civilization that ever existed since the Big Bang, that Albert Einstein was the smartest scientist who ever lived. Because there are hundreds of billions of stars like the sun just in the Milky Way galaxy. We now know that a significant fraction of them had a planet like the Earth. And frankly, when I look at the morning news, we are not that intelligent. But I wanted to refer to the UAP that was discussed. So I established the Galileo project 2.5 years ago, and we built an observatory that right now, as of the last few weeks, is collecting data about the entire sky all the time. And we are analyzing the data with machine learning to figure out if we are seeing only birds, drones, balloons, all the kind of things that Garrett referred to. And I can tell you that over 10 days, we had 20,000 objects. I'm talking about just the last few weeks. And we even had an anomalous signal that we are trying to figure out. So the point is, we are doing it the scientific way. We are the only project that was established following the scientific method for a systematic survey of the sky. When people report about UAP, it's anecdotal, meaning a military person was in the right place at the right time, and you can't calibrate the background noise that could have created whatever they see, and you can't replicate it. So I think it's a waste of time to just go back 10 years, 20 years, 50 years, the way that the All Anomaly Domain Resolution Office in the Pentagon is doing, because you can't verify the data. And we have fully controlled the instruments that are calibrated. We understand them. We look at the entire sky all the time. So if we keep seeing birds, I know how birds look. I'm happy to contribute the data to a zoologist. But the point is that we understand the background, the noise.
So I agree that sounds like a much better way to approach the problem. But okay, so I agree. I've encountered scientists who, for reasons of ego or even jealousy or other sorts of human flaws, behave suboptimally. Okay, like this is a thing.
Scientists have egos and jealousy?
A few of them.
Wow.
A few of them. All right, and not me. I'm fine.
It's
I'm
the
on
adults
up and
in
up.
the room.
But when I hear you talk about this, you present it as this is what the bulk of scientists are doing. And I don't know, I went around before in preparation for this event, and I talked to kind of every planetary scientist I could find. I said, what do you think about this? Blah, blah, blah. What do you think of this? And nobody said we shouldn't consider the hypothesis that this is technology. Literally none.
I'm glad to hear that.
And literally none said we shouldn't explore it further. Literally none said it was a invalid scientific hypothesis. That's not what people think.
But they're not doing it.
Well, some people are.
Who?
I mean, you can look in the archive. There are lots of papers on this. Right?
No. These are theoretical papers. Again, I'm not talking about opinions. I'm talking about collecting the evidence. Who is doing it? The Galileo Project is doing it.
Sure.
So it's very easy to say, I just don't have the time. This is an important subject. It relieves you from the duty of figuring it out. But suppose we would say the same thing about supersymmetry. We invested $10 billion in the Large Hadron Collider to find new particles that may represent the dark matter, most of the matter. We haven't found it. Now, people say, this UAP business, it's an extraordinary claim that requires extraordinary evidence. But they don't seek the evidence. And I say, extraordinary evidence requires extraordinary funding. Without investing the money and the time, you will never find it.
So let's use the Large Hadron Collider as a case example. So I think it's overly simplistic to say we built this machine to look for supersymmetry. That was one of a very long list of things we were hoping to test.
Which we didn't find. The Higgs was the only thing.
Well, I mean, we know a lot more about the laws of physics having run this machine. We haven't discovered many particles, but you learn how particles behave at high energies. You learn about the asymptotic behavior of QCD. You learn about, and by the way, every time you rule out a theory, you've learned something. And we've ruled out a lot of theories with the Large Hadron Collider.
But UAP did not receive it, or the
No,
search for
I'm going to get to
did
that.
not receive even 1% of this budget. 1%. I'm not talking about 50-50. 1%.
So hang on. So when we build a machine like the Large Hadron Collider, what we're trying to do is a long laundry list of scientific goals. Similarly, when we build bigger, deeper telescopes that can survey the sky in new and interesting ways, they're very rarely intended to do one thing, okay? So they're not designed to look for incoming extraterrestrial objects. They're not only designed to look for comets. They're not only designed to look at stars or galaxies or anything. They do a laundry list of things, right? So this astronomical community is very broadly supportive of spending money on bigger telescopes that can do things that our current array of telescopes can't do. And your passion targets are on their list. They want to do those things.
Well, let me give you an example that supports what you just said. We went after the materials of the first interstellar meteor, okay? And some of those people that are very critical and vocal may not represent the entirety of the, but those said, it's not interstellar and there is nothing to find there. We went there, we found it. Then I wrote a paper just a couple of weeks ago explaining the composition as originating from dwarf star planetary systems, okay? Which is a natural origin for this composition. Basically, an Earth-like planet can be destroyed by the gravitational tide of the most common type of stars, dwarf stars, like Proxima Centauri, in the Alpha Centauri system, the nearest star, which is 10% of the mass of the sun. So anyway, those people were not only objecting to the expedition, the hard work, but also objecting to even talking about an
You're talking about a very small number of people.
Oh no, just read the news reports that come out, for example, in the New York Times magazine, that they haven't covered science for decades, okay? They haven't covered the scientists. So they decided to do a profile about me, and then the reporter goes around for 8 months, speaks to people, and all he comes up with are negative remarks. Now, of course, everyone else might pretend to be supportive, but not do anything. It's just like those signs that I see in my neighbor's yard when I jog every morning at sunrise. I call this virtue signaling. Basically, people put a sign that they know that their neighbors approve. Okay? And then they feel that they are virtuous, but they're not doing anything to promote the cause associated with a sign. And moreover, if they really wanted to promote the cause, they would have to go to a neighborhood that doesn't agree with them and put the sign there. And they don't have the courage to do that. So I see the same thing in science, not just in politics, where people say, yeah, I mean, I'm in favor of that, but frankly, I don't have the time to do anything about it. And if everyone says that, there is nothing done about it.
So when I talked to, as probably a dozen or 15 planetary scientists over the month before this event, just trying to get my brain going and understand how this whole problem is viewed among that expert community. Again, everybody thought it was a valid scientific hypothesis. Everybody thought it was worth exploring. They were excited about future telescopes, so would be able to do it better. All of these things were true among literally every member of that group. There was one thing that several of them brought up, which they really didn't like about the role you're playing in it. And the thing they cited is, in a time where expert opinion and kind of objective truth is being denigrated and degraded, and our trust in institutions is at an all-time low, they think the way you're attacking the scientific community is risking making it hard for us to be taken as a reliable source of information when we really need people to listen, when we really need to convince the world that climate change is dangerous and the scientists know what they're doing when they're talking about it. If they've heard someone like what you're saying at this event or in your books say that these people are all acting for nefarious reasons and you can't trust them, well, then they won't trust us about those other important things.
I think exactly the opposite. I think I don't feel superior to the public, not intellectually and not in any other way. And for example, during the expedition, I wrote 43 diary reports. They were read by millions of people around the world, translated to Spanish. There were 50 filmmakers and producers that wanted to be on the ship. We selected only one. And the point is the public really wants to see how science is done. I got a huge flood of emails after the expedition saying, thank you so much for explaining how science is done. So I think the way out of the misperception of science is to communicate honestly about the scientific process that is full of mistakes and iterations until you figure out the truth based on evidence. And instead, what the scientists want is to just sit around the table in a press conference and tell the public what the answer is, which is sometimes wrong, by the way.
Well, what scientists want that? Because I don't want that.
Well, that's what you see always in the news. There is a news conference after the paper got accepted for publication where you tell the public what they need to know. And that is, I mean, the public should understand that it's a detective story, and the public likes detective stories when the answer is unclear until you figure out based on evidence what it is. And that's the way I see it, and I feel that it's important to communicate that way, that, you know, that we have a small island of knowledge in an ocean of ignorance, and we're trying to push the frontiers of knowledge. And I am not pretending I know more, and I want to figure out the evidence, which is...
So nobody is complaining that you're communicating to the public.
Mm-hmm.
Nobody is complaining that you're showing people the day-to-day operations of the scientific experience, the scientific process. What they're objecting to is when you say this, you can't trust the scientists because they're all acting out of jealousy, they're all acting out of petty ego, and they're lying to you. That is what the objection is.
So what's interesting in this is I think that this is not just a debate in the scientific community, right? That, you know, one of the things that you sort of see across the sort of 80 years of the modern flying saucer UFO UAP debate is this rising sense in the public of a government cover-up around the government's knowledge and understanding and theories around UFOs and their knowledge and understanding of extraterrestrial civilizations. Now, what's interesting is as you get into this, there absolutely is a government cover-up around UFOs. I don't think it's the one that we think it is. which is that there are sort of multiple layers where we know that a government cover-up exists. You know, some chunk of UAP sightings are our own secret government projects and planes and technology. As it turns out, we now understand about 50% of all UFO sightings in the 1950s were actually tests of the U-2 spy plane. That was a UFO. It was a plane that didn't look like a known plane, flying at an altitude that planes were not known to fly at speeds planes were not known to fly. We now know that, you know, some chunk of UFO sightings in the 60s and 70s and 80s were the development of the SR-71, the stealth bomber, the stealth fighter. There, we know that the government has sort of secret planes and operations that it's doing right now. Some chunk of the government cover-up is because, again, some of this is adversarial technology being tested against us, and the government gets real hinky about what its sensors picks up and don't pick up. This is why sort of Avi's project to sort of have an open catalog of sky stuff is interesting and useful because the government doesn't really want to tell us what they pick up.
Sometimes for good reason.
Sometimes for good reason. And remember, this exists in much wider than we normally remember. You know, if you think back to the Titan submersible this summer, after they found the Titan wreckage, the government came out and said, oh yeah, actually our undersea anti-submarine surveillance system heard it explode in real time, and we've known that everyone was dead from the second that the thing imploded. And they were like, we didn't really want to tell anyone because we don't really like talking about our anti-submarine surveillance system. Then you get, though, to what I think is at the core of the government cover-up, which is the John Brennan answer, which is it's an incredibly uncomfortable place for a bureaucracy to not have answers. That scientists can be humble about what they know and don't know. It's a lot harder for governments and bureaucracies to say, there's something here, we don't know what it is, and we spend $60 billion a year on intelligence, we spend $800 billion a year on national defense, we spend $100 billion a year on homeland security, and there's some stuff up there that we're not really sure what it is, and we don't really want to tell you that. And when you look back across 80 years, I'm much more convinced that the government cover-up is this core of ignorance than it is anything that actually is sort of material knowledge of technologies that are out of this world.
So what would it take, this is a question for both of you, what would it take not just to convince individuals, but to convince like the mainstream scientific community, or for that matter, the mainstream population, that we are or have been visited by technologically advanced extraterrestrials or their hardware?
Well, it's very simple. We need a high-resolution image or video that shows an object that was that looks technological, because it doesn't look like a rock, doesn't look like a stone, as the way some of my colleagues want to interpret everything. It has screws and bolts on it, and it moves in ways that we cannot reproduce. Okay, that's very easy. You just have to need the data.
When you picture I want to follow that. Let's say we had an image of Oumuamua. What do you think it would look like?
Well, it depends what it is, but
just for the audience, we can see it, but it only looks like one pixel of light. We can't produce an image, so we don't know what it actually looks like.
Right, because it's roughly the size of a football field, and it was at a great distance of roughly 1/10 of the distance of the Earth to the sun, so we couldn't resolve it. It's tiny. But, in principle, it could be a piece of a broken Dyson sphere. I thought about that. I wrote a paper about that. So a Dyson sphere is what Freeman Dyson, about 60 years ago, imagined, that advanced civilizations would surround our star with a megastructure that will harvest the light from the star. And the most practical way to do that is to have tiles that are free floating above the star so that radiation pressure from the star is balancing gravity. So they are just hovering like kites over the star and collecting the energy. But when the star evolves after a few billion years and becomes brighter, it will push away this structure and they would become interstellar objects.
And thus the pancake shape.
So that's an example of something I can imagine, a piece of a thin tile from a Dyson sphere. So I wrote a paper about it. But this is just my imagination, which is quite limited. Now, in the case of the Pacific Ocean object, we want to go again and find a big piece of it. And in my freshman seminar class at Harvard, I asked the students, suppose we go there and find a gadget that has buttons on it, which is, again, clear evidence that we're not dealing with a rock. Should I press a button? And half of the class said, no way, please don't do that, it will affect all of us. And the other half of the class said, please do, we're really curious to figure out what will happen. Maybe it's, iPhone 100 or ChatGPT 50 or whatever. And then a student raised his hand and said, Professor Loeb, what would you actually do? And I said, well, I'll bring it to a laboratory and study it before engaging with it. But these are just two examples, a high-resolution video or finding at the bottom of the Pacific Ocean a gadget that humanity never produced. Clear evidence, a kid could figure it out.
I think I agree.
And this, to me, by the way, is part of why this subject is so fascinating to us. Like, I'm sitting here on stage, and you guys are both like dark matter, black hole experts. There is zero chance in my life I'm going to make a meaningful contribution to the science of black holes. There's very little chance I'm going to stumble upon sort of fusion energy in my garage on the weekends. UFOs is something that sort of any one of us could potentially participate in solving. Like anytime we look out a window, look into a sky, sort of walk through the woods. And that to me is like part of why I think this is such a intense human subject of fascination, because it is a subject that sort of any one of us could help alter the entire understanding of sort of humanity and our cosmic context.
There is one more, I just want to add a footnote. There is one more reason why it's so appealing to people, and that is it's similar to spirituality in terms of exploring the unknown. And I actually stated that the very advanced scientific civilization, I talk about it in my book, is an approximation to God. Because in principle, it may have reached the point where they can create life in the laboratory. We are almost there. Or they understand quantum gravity well enough to create a baby universe in the laboratory. These are attributes that we assign to God in religious texts. And just think about the fact that, if someone, a cave dweller would walk in New York City, what that cave dweller the cave dweller would be filled of religious awe, looking at all these gadgets. And so it's possible that when Moses saw the burning bush that was never consumed, nowadays we can place a burning bush that is never consumed in front of Moses, and he would really be at awe and think that God produced it. What I wish is that I was next to Moses using the infrared cameras of the Galileo project and advising Moses about how unusual this object is and whether it was indeed produced by a superhuman entity. So I think that's also appealing to people to realize that God is not just stories. It might be out there.
So I'm being told that we're on to the Q&A section of the discussion. So thanks, both of you, for those great answers and discussion.
If you have a question, please raise your hand really high and say your name and keep it as brief as you can with this very detailed topic.
Here we go.
Hi, I'm Brad Moody. Thanks for your talk. Opinions on the Fermi paradox, number one, and then closer to Earth, opinions about the United States Navy video release from the last couple of years of UAPs.
So before we answer, I'll just set the table, at least on the first part. The Fermi paradox, for those of you who might not know, is coined after a conversation between the great physicist Enrico Fermi and the other great physicist Edward Teller. And basically, they were estimating how much intelligent, technologically advanced life there should be out there in the galaxy, and they couldn't understand why we hadn't seen a lot of it. So the question, the paradox is, why isn't the evidence of technologically advanced civilizations more abundant?
And I will answer a question that you didn't ask related to this, and then let Avi actually answer your real question, which is one of the things people miss in talking about the Fermi paradox is it is the clearest evidence that we have that there is no government cover-up that stretches back to Roswell. Because the thing that people miss is that the conversation where the Fermi paradox is born takes place in the early 1950s. They've traced it back because it was based around a specific New Yorker cartoon that inspires the conversation, and they know the date that that cartoon ran. The thing that people misimagine about if there was a crash at Roswell that was meaningful, and I can tell you the story of Roswell, or you can read the book and understand why it's not the thing anyone thinks it is. But if a crash had happened and a craft had been retrieved in 1947, it wouldn't have gone to Wright-Patterson Air Force Base in Dayton, Ohio. It would have gone to Los Alamos. Los Alamos is where the nation's smartest scientists and physicists were working that summer. It also is pretty close to Roswell. So there's very little reason the government would have bundled up this craft and flown it all the way across the country to Ohio, to a heavily populated area with military personnel, when they could have sort of just trucked it across the state to Los Alamos, where Enrique Fermi and Edward Teller would have been among the first scientists working on it in 1947. So that's my little twist on the Fermi paradox history for you.
Yeah, so first I wanted to say that I really admire Enrico Fermi. I mean, I just visited the statue that is on the place where he built the first nuclear reactor here at the University of Chicago. And I read many of his writings at a young age. And I think, if anyone watched Oppenheimer, the film, I think Enrico Fermi was probably responsible for the success of the Manhattan Project more than anyone else, because he understood both the theory and the experiment. And that's why I'm puzzled by his question. He asked, where is everybody? In an Italian accent. If you stand at home and you say, well, there is nobody next to me, and you say, well, maybe I'm alone. Any kid will tell you that in order to find partners, you need to go out of your home and search. Go to dating sites, at the very least, look through your windows. And he didn't even use a telescope. So why would they come and visit him at lunchtime at Los Alamos, during the time that he was looking around? I mean, they could have visited Earth millions of years ago. That's a very bad question. It's not the right approach. But if you ask me what could be the answer, there are more than 50 answers that people suggested. But mine, based on recent events, is, first of all, it's very likely that if they get to our stage, we developed our science and technology over the past century, and it's not clear to me that we would last more than twice that long because of what you see around the world, because of the risk that the technologies we develop can destroy everything, okay? And the existential risk is real. If a terrorist organization gets a hold of a nuclear bomb, it could create a third world war where there will be a lot of damage all around. And so, another possibility is that, they went in the direction that Mark Zuckerberg advertises, which is to put goggles on their head and live in the metaverse. or they take recreational drugs. So when a civilization reaches a point where they live in a virtual reality and misinformation is filling up the news, they will never engage with the actual reality that allows them to explore space. And they will perish soon afterwards because they don't adapt to changing circumstances. So the real risk to our civilization is misinformation, which is promoted by social media, and the tendency of people to believe in a virtual reality that is more flattering to them. They can live in a house next to celebrities in the metaverse. And just imagine all these aliens putting goggles on their head and living in the metaverse. None of them would come here. So that's one possible answer that could explain why they're not so prominent. But it's also possible that they are so much more sophisticated than we are that we haven't noticed it yet. We are just like a colony of ants on the pavement when a biker is passing by. So, for example, if an object moves at a fraction of the speed of light through the solar system, no astronomer would notice it because they will just get one snapshot of that object and say, well, that's just a fluke. We don't know how fast it was moving too fast. Or if it's a small object, smaller than a football field, we would never see it from the reflection of sunlight. There could be a lot of things around us that we haven't yet noticed, not to speak about the fact that the physics that we have is incomplete. We don't have a theory that unifies quantum mechanics and gravity. We don't even know what most of the matter in the universe is. Just think about it. People get Nobel Prizes for doing the accounting, just saying what is the fraction of matter that we don't know relative to matter that we know. For that, they get a Nobel Prize. That just shows ignorance. We don't understand the very basic composition of the universe. And so it's clear that we are missing something. And it may well be that we can't see them because we haven't figured it out yet. If their engines are fueled by dark matter, for example.
And then I'll give you an answer on the Navy question also, which is a big part of what has driven the public interest in this subject since 2017, when the New York Times and Politico both came out with stories sort of looking back at a resurgence of UFO, UAP-related research that Senator Harry Reid had actually helped fund and drive during his time in office, has come out of a series of videos that primarily the Navy has released of UAPs. UAPs, of course, is the government's latest rebranding of this subject to try to downplay the giggle factor and destigmatize conversations around UFOs. The irony is that it was actually the U.S. government's first iteration of a UFO program that was known as Project Blue Book in the wake of, in the early years of the Cold War, that first popularized the term UFO as a way to destigmatize what the public had been calling flying saucers. So UFOs was the government's first attempt to take this more seriously. UAPs is now a term meant to sort of encompass, first they called it unidentified aerial phenomenon to make clear that not all of these things were necessarily objects. Then they renamed it a third time unidentified anomalous phenomenon to make clear that not all of these things are aerial, that we are looking at things that could exist, for instance, in the water. And that these Navy videos show a variety of objects that the Navy pilots who encounter them say, Navy aviators who encounter them, say, sort of surprise them, puzzle them, and appear to not adhere to the laws of physics and propulsion as we currently understand them. To me, I'm not in a great position to sort of judge the veracity of these videos, except to say, again, coming back to my sort of reasons around the government cover-up, the government should be more interested in figuring out what those things are. The puzzle to me is if you have Navy aviators coming back to military vessels with documentary evidence of something weird, that's precisely the types of things that I would want the U.S. government to be trying to solve. And the fact that the government has not made a serious effort to try to solve those over the last 25 years is really disheartening to me. And there's a lot of there are a lot of interesting answers, again, of what those things could be if they exist at all. And there's some reasons to doubt that they exist at all, where the answers could be interesting and meaningful and still not be an alien coming from Alpha Centauri to buzz the USS Nimitz.
Do we have time for another question?
We will do one last question, and as a reminder, we will be having a book signing downstairs on the first floor lobby if you're interested with talking with these gentlemen even more.
Oh, hi, thank you. I'm Jessica, and thank all three of you. And I haven't read either book. I just want to say that. But I guess I was curious. Well, I'll say I was struck when Dr. Loeb was talking about the involvement of the public in this pursuit, and I still feel like there's some tension maybe around if the public really does have a role. Like, does it need huge funding and actually lots of technology to answer these questions, or a lot of scientific theory, or does the public really have a role? And in fact, you want all of us out there looking for UFOs and other unidentified objects. So
That's an excellent question, and in fact quite timely, because a week ago we detected an anomalous sound with our microphones at the observatory at Harvard, and we just couldn't figure it out. It wasn't like anything atmospheric that we've heard before, or it wasn't an airplane for sure. And so we needed to know the distance, and we wanted to triangulate. So for that, we needed another sensor far away from the observatory. And we tweeted and on Instagram put a request to the public, whoever has data, to provide us with, or if they have security cameras, to give us the data. So this really came to fruition. And this post got 200,000 views within a day. And we did get some data. But in general, I'm not in favor of using, public data that is from instruments that are not well understood. But this is an example where the public could really help us. Other than that, we built an observatory for $500,000, working. We know exactly what needs to be done to make copies of it. So we're making a new copy to put in Colorado. And then we want to have hundreds of copies throughout the US so we can monitor the sky from many locations. And all we need for that is funding, that's all. And at $500,000 for an observatory that could be named after the donor, that's not a lot of, as I said, hundreds of telescopes like that would be just 1% of the budget of the Large Hadron Collider, which, believe me, just confirmed old news from the 60s about the Higgs boson. How particles interact, strongly interact. That was not news, okay? It was trying to find new particles, didn't find it. For $10 billion.
Avi, one of us on the stage is a particle physicist, and it's not you, and you are wrong.
Okay, so tell me what it discovered.
If you open up the particle data book, which is the place where we accumulate all the information we know about elementary particles, their characteristics, their interactions, the laws they obey, it is transformed relative to the day that machine turned on.
Okay,
and
so
it's
the precision of numbers, you mean?
Yeah, that precision is very
important.
important.
Yeah, but I'm talking about new knowledge, not about, Michelson. Actually, here at the University of Chicago, there was a new laboratory constructed around 1890. And Michelson, a very prominent physicist, gave the speech and said that from now on, physics will be about measuring the fundamental constants to the 5th decimal point, which is pretty much what you're describing, trying to get more precise numbers. And boy, he was wrong, because just a decade later, Albert Einstein came up with special relativity. Another decade later, general relativity. Another decade later, quantum mechanics that revolutionized physics. So I'm talking about those kinds of new knowledge, not about the fifth decimal point of a parameter that we already knew.
So I would have been more excited if the Large Hadron Collider discovered a slew of new particles and interactions and new forces. Agreed, all right? That is what we hoped would happen. But you build machines that are capable of discovering new things, and you learn what you learn from them. But the Large Hadron Collider did teach us a lot. And one thing they taught us is that a long list of theories we used to take very seriously aren't true, aren't manifest in nature. That's valuable.
Well, let me give you an anecdote on that. I was having breakfast with a string theorist. And by the way, the string theorists are not my best friends. And I asked this string theorist, who is one of the leaders, I said, what is your most important paper throughout your career of about 50 years, okay? And he said, it's a paper about supersymmetry. And I said, really? But we didn't find supersymmetry. And he said, well, it's just around the corner. We'll build a bigger, we just need to invest a few more tens of billions of dollars and we'll find it. And I was reminded of the Orthodox religious community of Crown Heights, the Jewish community in Brooklyn, who believed that their rabbi will become the Messiah. They believed it so much that they built an apartment in Israel that is a replica of his apartment in Brooklyn, such that he will find the toilets easily when he comes back after he dies as the Messiah. Now, that was the theory, just like supersymmetry. Then the data point was that he died and never came back. Okay, they were faced with a data point, just like supersymmetry is not found. What did they say in response? Oh, it's just around the corner. Let's wait. And
so, but hang on, but that's not how the community that you're describing responded to it. You're caricaturing them, and it's irresponsible. What we said before the machine turned on is, this is a hypothesis. There's a chance that if the hypothesis is true, this machine will see it. There's a bunch of other hypotheses this machine will be able to test too. Then we took the data, we updated what we believed based on that data, and we have a lesser credence in supersymmetry existing than we used to. It doesn't go to zero, but it changes. We learn things and we adapt. We aren't keeping our head in the ground. We aren't ignoring evidence. We aren't behaving outside of the boundaries of the scientific method. We are trying to learn as much as we can with the best tools we have and the best information we have about the laws of our community.